Hey there, in this video we're talking about constructors and destructors in C++ object-oriented programming. And this covers sections 13.7 to 13.10 in the Gaddis textbook. Now remember, we're at the point in the course where we're thinking about being a member of a team of programmers working on a big project. And we're thinking that we are providing services to the other programmers to make their life easy, or we're receiving services from one of the other programmers that are actually making a class for us. So the theme for today is how can we make our objects automatically initialize themselves, automatically set themselves up appropriately to begin with, or automatically clean themselves up at the end without any work at all from the application programmer. Hopefully we can make that stuff happen all automatically, and that is the point of constructors and destructors. So once again, going to make things much more efficient for our application programmers when our classes have these features in them. All right, so first part of the story, constructors. A constructor is a member function of a class that is automatically called when an object is created. And the purpose of that is to set up or initialize the object automatically. Object probably has a whole bunch of member data, a whole bunch of member variables, and the constructor is going to set them up appropriately for an initialization to begin with. So some examples of that would be initialize your variables appropriately, could be dynamically allocate memory that this object needs to use, could be open a specific data file that the object needs to read from. These are all really common uses of constructors. That's really why constructors exist, for that kind of stuff. Now, I'd love to think about that. How many times in our course have we talked about when this variable gets created, what's stored in it initially? And we've said random garbage, that's an uninitialized variable. And if you try to use that in some math or print it out, you're going to get nonsense results, right? You don't initialize a variable, random garbage. That's been a problem over and over again for us. Well, if you've got an object and the constructor is set up correctly, that'll never be a problem again. The objects will just automatically initialize their internal variables appropriately, and that whole problem, gone forever. Great. Love it about object-oriented programming that the objects will initialize themselves as needed automatically. No work will ever need to be done again for that, which is awesome. Now, assuming that you want to use this feature, which you do, here's how you do that. The constructor function name is exactly the same as the class name. So if I have a class called matrix, the name of the constructor function is matrix. No question about it, spelled exactly the same. Constructors have no return type, not even void. There's literally no return type before the name of the constructor function in the prototype. Okay, let's take a look at that. So here is an example of our old Rectangle class. And remember that we've put the class definition in a dedicated header file called Rectangle.h. We've seen this before. We've seen all this before. There's one tiny little change here, and it's on line 12. Here we are now defining the constructor for the Rectangle class. And just like we said, it's a function prototype. There's no return type. You don't even see void for the return type like you see on 13 or 14 below it. The name of this constructor function had to be rectangle. The compiler won't permit anything else. And there you go. There's a prototype for a constructor. Now remember, we're assuming that Alice is our class programmer, so probably Alice added this to the header file. Now Alice has to go implement it over in the source file. Let's go see that. So of course, this is over in rectangle.cpp, where we include rectangle.h. And here's Alice implementing the constructor. So as usual, the full name of this member function is actually rectangle, scope resolution operator, rectangle for the constructor. Doesn't take any arguments. All it does is, of course, our rectangles have two pieces of member data. There's the width and the length. Is they initialize width and length to 0, which are reasonable default starting numbers, right? It doesn't make sense to be negative. You probably don't want these to be a million. So we're just going to, every time you make a new rectangle object, it's going to initialize those variables to 0, and they'll never have random garbage. You know when it starts off, it's always 0. Great. So Alice has done her job. And now we'll look over at the application, and presumably this is Bob's job. He's actually doing something with a rectangle. So he's included Rectangle.h, and he is instantiating. He's creating a rectangle object on line 8. He's called it box. And when he does that on line 8, that's when the constructor runs, right? Bob doesn't have to do any other work for that. You don't even see it. He might not even know that it's happening. But as soon as he makes a rectangle object on line 8, the constructor automatically runs right there and makes the width and the length 0. Bob does no work. And I'm sure Bob's very happy about that. So then for a test here, we just print out the rectangle's data. We print out box.getWidth and box.getLength and box.getArea. And as you can see here, the book is showing us that you actually are going to see the 0 and the 0, and of course the 0 for the area. So that's pretty nifty. That's the point of constructors, right? Bob has done absolutely no work whatsoever. He's just made a rectangle object like he normally does on line 8, and the constructor automatically ran and automatically filled in legitimate data, not random garbage, into those members. Now, a little side point about this. Notice that this program takes no user input, right? It's a very short program. Doesn't really do anything super useful, frankly. Okay, I have a box that's size 0 and 0. But the point of this is one of our test drivers. The point of this is to prove that you can make a rectangle object and that the constructor does run and does do the right thing of initializing the data to 0. So we've said this before, but our labs will look more and more like this. Our assignments will look more and more like this. Read the assignment specifications carefully to future assignments. Sometimes I have students that they assume that's always a bunch of sin statements. Like, just even if you don't say anything, some of my students just like, okay, here comes sin, 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 and the user's entering data all the time. We're going to stop doing that, right? We're going to be thinking about being in the context where we're working on a big team. You're not the application programmer, you're the class programmer, and you need to test your class and just make sure that all the member functions work properly, including the constructor. So read the assignments in the future very carefully. Most of our stuff in the future will not be taking user input. That's a job for an application programmer in our imagination further down the road, and we're not worried about that anymore so much. Okay, so just kind of keep that in mind. The work of our course, starts to look more different as we're working at a higher level, frankly, going forward. Okay, so that constructor ran there. Bob didn't even have any option about it, right? He couldn't avoid the constructor running even if he'd wanted to. Zeros were going to get set in the width and the length for that rectangle automatically. But here comes Kathy, okay? And maybe Kathy's working in a different kind of program and she wants to take control of the starting length and width. Well, you can do that, right? And again, we ought to provide that flexibility in these different services to different programmers. So if you want to give the application programmer the option of specifying the starting numbers, you can do this. You can make a constructor that takes arguments. And it would be very smart if my rectangle has a width and a length member to make the constructor take two numbers, and those two numbers are going to be recorded in the width and the length as the object gets created. Of course, that would make sense. So your constructor can take arguments. You can indicate parameters in the prototype. So here I have a prototype to a rectangle constructor, and it takes two arguments that are doubles, the same as the member types, of course. Remember that the names of the parameters are optional in the prototype, so we're in the habit of just indicating the types there. That would go in the header file, of course, for the prototype. Then when this constructor is implemented over in Rectangle.cpp, of course, you have to give the parameters names. And of course, the full name is, again, rectangle : rectangle. It's in the rectangle class, and this function is called rectangle as well. So in comes the two pieces of data there, and we would record it in the width and the length members like we normally do with setters, basically. Okay, and then third, of course, you're going to use that when Kathy makes her rectangle. She can declare a rectangle object. She's going to call it R, and it looks like a function call, right? So you can put down parentheses 10, 5, and those are the numbers, the 10 and the 5, that are getting sent into the constructor here for the W and the len, and of course those wind up sitting in width and length by the time you're done. So take a look at that. I think that's new, right? Calling a constructor with arguments, the actual instantiation of the object looks like a function call because it is. You're calling the rectangle constructor with those arguments. Very, very common. Make sure you're familiar with that right there. Probably the first time we're seeing that, but I think if you look real carefully in the past, creating a file object, you can do the same thing with it. Creating a string object, you can do the same kind of thing. And that's what's happening there is you're passing arguments to a constructor. Overloading constructors. Remember this term overloading means you can have different versions of a particular function. You can have separate functions. They have the same name. That's fine. But for the compiler to distinguish them, you've got to have different parameter lists. So you can do that with any other types of functions. And you can do that with constructors too. And this is super common because I know that I'm giving services to a bunch of different programmers. They want to interface with my class in different ways, and I want to provide access in ways that are convenient for them. So a pretty good example here is we could expand the rectangle class. Again, for this to work, you've got to have different parameter lists. That's how the compiler tells the difference. So maybe Bob doesn't want to worry about it. He just wants to make a rectangle, and he just wants the width and length to be 0. So for Bob, we've provided this rectangle constructor that takes no arguments, and it just fills stuff in with 0. Now maybe Kathy comes in, so maybe what Kathy's actually doing is she's actually dealing with squares. So what Kathy wants is she wants a constructor where she can specify one single number. That's going to get set for both the width and the length, and then Kathy basically has a square. Great. I mean, that's what a square is. It's a rectangle with the width and the length the same number. Great. And then here comes Dennis, and Dennis actually needs rectangles that are initialized with different widths and lengths. So we do this for him. We provide a rectangle constructor that takes 2 numbers, one for the width and one for the length. Okay, so however the application programmers are interfacing with my class, I've given them the capacity to do whatever is convenient and efficient for them. Makes a lot of sense. We usually do this with classes. Classes usually have a bunch of overloaded constructors to make it really easy for the application programmer to do whatever they need to do with as little typing as possible. Now, every class has a constructor. You actually can't avoid it. And even if you try to avoid it, your class is still going to have what's called a default constructor. And to be clear about it, the default constructor is the constructor that takes no arguments at all. So the one where the parentheses are just empty, that's the default constructor. Now, if you, the class programmer, don't write a constructor like that for your class, C++ is actually going to compile one anyway for you. And it's going to be sitting in memory, and it's going to be effectively blank. But there needs to be a default constructor. You don't have a choice about it. And C++ will actually fill one in. Again, you're not going to see it in the source code, but in memory it's going to be there, a default constructor that does nothing. And when you do an instantiation of a class, right, you're just making an object, you don't put down parentheses, that does call the default constructor automatically. So if Bob just writes down rectangle R, right, of the several constructors that we were looking at previously, that, writing it like that, calls the default constructor the one with no arguments. So even that is triggering a constructor call, and you can't avoid it. It's going to happen automatically with C++ objects. Now here's the other side of the story. So the flip side of the story are called destructors. And destructors are member functions that are automatically called when an object is destroyed, when it goes out of scope. So remember, if you're working in a function and you make some local variables, or structs or objects, when the function ends, all that local stuff is scrubbed out of the memory system. Okay, so that's what we mean by going out of scope. When an object goes out of scope, this type of function, the destructor, automatically gets called. You can't avoid it. Now, the purpose of that is to clean up and free resources. For example, if the constructor dynamically allocated memory, remember you got to delete it, well, the destructor should delete the dynamically allocated memory. If the constructor opened up a file, then the destructor is in charge of closing the data file. And again, all that stuff is going to happen automatically without any work on the part of the application programmer. And let's think about how important that is. Since we've been working in chapter 9, 10, 11, 12, right, we've been dynamically allocating data once in a while, and we're supposed to delete it at the end of the program, but how many times have we forgotten? We've forgotten that so many times over and over again. It's a common problem to forget to delete dynamically allocated data and then wind up having memory leaks in your program. So this is the problem that destructors are there to solve. When the class programmer makes a quality class, they're in charge of that. You've got a constructor, and that's the one place where the memory is allocated. And then the destructor, well, that's the place where you delete it, right? And the class programmer just has to set that up once, and now the application programmers, all that stuff just happens automatically, and forgetting about the deletes is just gone. Problem solved, will never happen again. That's great. And same with files. If you open a file, don't forget to close it. Well, we'll put that in the destructor and it will happen automatically. So assuming you understand how important and how useful destructors are, here's how you make that happen in C++. The destructor name is automatic. You don't have a choice about that. It's tilde class name. And tilde, that little symbol right there, it's up on the top left of your keyboard, if you're unfamiliar with that. So remember, the constructors are just the same as the class name, while the destructors are tilde the same name. So the destructor in my rectangle class would have to be called tilde rectangle. No choices about that. Again, the destructor has no return type, not even void. Doesn't take any arguments. You don't have any choice about that either. Destructors are just getting rid of stuff that's inside the object, so there's no point in sending arguments in because it already knows what data is there, it just has to get rid of it. And here, this is different from constructors, every class has exactly one destructor. There's no overloading. Again, there's no arguments, therefore there's no overloading, and every single class only ever has one single destructor. Now again, if the programmer doesn't provide one for the class, C++ will again create and compile one automatically, a destructor that does nothing. But every class has to have a constructor and has to have a destructor for C++ to work properly, so it'll actually just compile it anyway, even if you don't write one. That's all very handy. You can see how much stuff is happening automatically now with object-oriented programming. So much stuff is suddenly getting taken care of for us. So here is program 1311 that is an initial demonstration of constructors and destructors in action. And honestly, this is such a silly program, but it just kind of hammers home when the constructors run and when the destructors run. So it's a little class. It doesn't even have any member data whatsoever. It's just got two functions. The class is called demo, and on line 8, you've got the constructor, specifically the default constructor with no arguments. It's called demo, of course. And on line 9, you've got the prototype for the destructor, which is, of course, named tilde demo. You don't have any choice about that. Here is the implementation to the demo constructor. It just prints something out. It prints out welcome to the constructor. And here's what the destructor does down on line 17, 18, 19. It just prints out the destructor is now running. Now, these are not things you would ever want in constructors or destructors. You don't want printing statements or counts in constructors or destructors. That is not the point of constructors or destructors. Again, constructors are meant to initialize data or allocate memory or open a file, right? And destructors are meant to deallocate memory or close a file, right? You don't want count statements in them. But just for demonstration purposes, just to show that they're happening, that's what's happening in program 1311. So here comes the main function. And on line 28, they create one of these demo objects called demo object. That seems like a good name for that. Okay. And then it prints out, this program demonstrates an object with a constructor and a destructor. And then it returns. Okay. So the question here is, and you can kind of see if you run this program, what gets printed. Well, that's interesting because some of that stuff wasn't in the main function. So the question here is, when did the constructor get called? And when did the destructor get called? Because both of those things actually happen here in the main function. And presumably if, Bob, the application programmer, wrote this, he didn't have to do any work for it. So when did the constructor actually get called and when did the destructor get called? And the answer is going to be the constructor get called on line 28. As soon as you make the object, the constructor happens. You don't have any choice about it. You're not going to see it. You can't avoid it. Happens automatically. And the destructor got called right after line 32. When line 32 happens and you jump out of this function, the demo object gets scrubbed from memory, and that's when the destructor runs automatically and you can't avoid it. And that's the results you see here from the program output. We should test that and maybe even do that in the debugger to be sure about it. Okay, so here is program 1311 in the IDE here. A very small, very simple program. It's just got one file here. Of course, it's got the class definition plus the implementation plus the main function all in one file, which we're not doing so much anymore, but that's fine. So your definitions, the constructors, here's the implementation, constructor, destructor. Here's the main function. Again, probably Alice did this stuff up on top. Probably Bob is writing the application or somebody else, and just makes an object, does some printing, returns, and you can compile this. Those are executable there. And of course you can run this. And just like the book said, this prints out, welcome to the constructor. This program demonstrates an object with a constructor and a destructor. The destructor is now running. Now, if Bob working down here didn't know about how object-oriented programming works, he might possibly be mystified about where did this printing come from? Because my main function doesn't have that count statement. I don't even have a function call, so where did that come from? Now I know what this is because these are the count statements in the main function. And then he'd also go, I don't understand where this is coming from because again, there's no count statement and no function call to do that. So, but we know, of course, how constructors and destructors work. So let's, just to highlight that, let's just step through this in the debugger. So I'll put a breakpoint here on the very first line of the program. And I'll start debugging this. So as usual, the program is now running, but we've paused it on that line 28. So nothing's happened yet. But line 28, of course, is instantiating the object. It's making a demo called demo object. And what you'll find is that's the line that's automatically calling the constructor. So it doesn't look it, but if I click this into function button, you'll actually see us jump into the constructor up on line 14. Now we're on line 14. And just creating the object did that automatically. So obviously that line is what's printing out welcome to the constructor. And as we come out of this function, we'll go back to the main function, right after that line there. So now you're on line 30. And you do the normal thing here, of course. This prints out, this program demonstrates an object. And this line here prints out with a constructor and destructor. Okay, now I'm on the return statement. So I'm jumping out of the function. Okay, at this point, that demo object is going to get scrubbed out of memory as it goes out of scope. So now if I click into function, okay, the IDE just got a little confused there. But what really happens is that jumps you into the destructor. At the moment when that main function is ending, when that object goes out of scope, it automatically jumps you into the destructor, basically on the return line. And then line 19 obviously happens, and that's what prints out the destructor is now running. And then you come back right to the end of your main function, and the program does some cleanup work for Windows, and then the program's over. Okay, so hopefully that highlights exactly how the constructors and destructors work. Constructor happens automatically, you cannot avoid it when you make a new object, and the destructor runs automatically, you cannot avoid it. When that function ends, or when that object otherwise goes out of scope. Now again, this example is not what you want to use. It's not why you want constructors and destructors. We should see another example that better illustrates that. All right, so the demo object example, such a silly example, right? It's just printing stuff in the constructor destructor, not what you'd ever want to do. Here is a better example. So in the book, this is ContactInfo.h. So this here is the definition of a class to store personal contact information, a name and a phone number. And remember, the point of constructors and destructors is probably to do dynamic memory allocation and then clean it up with the deletes in the destructor. And that's what this class does. So this is a much more legitimate example. Very important, and I hope you'll look at this very carefully. So ContactInfo.h, of course, this is sitting in a header file. You got to have the include guards, no doubt about that. Here's the definition of class ContactInfo. Now, you do have some private data here. These are pointers. You have a character pointer called name, and what that's going to do is it's going to be pointing at some dynamically allocated memory that's spaced just the right size for a person's name. And then on line 11, you have a character pointer called phone. Again, we're going to allocate memory. This pointer is going to point to that, and that's going to have exactly enough space to hold a person's phone number. Here's a constructor, line 14. So of course the constructor is called ContactInfo, and in this case the constructor does take two arguments, a character pointer to presumably somebody's name, okay, and then another character pointer presumably to some phone number, and we're going to copy that into memory that this particular object controls. So notice that here is the actual implementation to the constructor. It's written inline in the actual definition of the class. I'll talk more about that in a couple seconds, but here's what it does, is it dynamically allocates memory. This is the kind of thing you want to see it in constructor. It dynamically allocates just enough memory for the name and the phone number. So you're passing in a pointer to a C string that we called n, and what we do is dynamically allocate. We make a new character array that's the length of that string plus 1. Why the plus 1? For the null terminator, right? You need the actual characters and the actual name plus 1 more for the null terminator. So you dynamically allocate on the heap. You get your operating system to go find just enough bytes, exactly enough bytes, to hold that name, returns a pointer to where we found it, and you store that address in the name pointer. Same thing with phone. So you dynamically allocate a new character array that's the length of the P string, plus 1 for the null terminator, right? Windows or whatever goes and finds that much space in the heap, that many bytes, reports back where we found it, and you hold that address in this phone pointer, right? Great. And you think about what we did in the past, right? In the past, we've been making like, a fixed name C string that's sized 51 or something just to be safe. Well, I mean, most names aren't 50 characters, so we were wasting all that space before. This is better, frankly, to dynamically allocate just enough space, and you're not wasting bytes all the time on normally shorter names. So smart. And then what we're doing is we're calling, because that just allocated the space, and of course we have to copy the incoming C strings to these new arrays that we just created. So we call those string copy functions back from chapter 10, and we copy all the characters from n into our name area. And of course, name's a pointer, but you can treat it as an array. And that's what string copy wants to see. So copies all those characters in, do it again, copy all the P characters from that string into our phone string, and now we have recorded a copy of that name and that phone number that we're controlling. And so that's the constructor, right? Dynamically allocating exactly the right amount of memory to store that information. And probably, I expect on the next slide, I expect to see a destructor. There you go. Now that's really simple. Of course, the destructor is called tilde contact info. It's written in line, and you delete the array called name, and you delete the array called phone number, so you don't have any memory leaks. Of course, that's what you want to see in a destructor, of course. And this class also has a couple accessors, right? Here's getName that returns the character pointer to where the name is. And here's getPhoneNumber that returns the character pointer to where the phone number is being stored. Of course you need those accessors. So that's okay. My one complaint about this class is that the inline functions are too long. Let me just go back for a second. So we have said that inline functions are okay for 1 or 2 lines. You don't want your class declaration to go on and on too long. You kind of want it to fit on one screen. So that's not great. I think that could have been improved with, I would want to find a way to if I am going to use inline functions, I want to find a way to make it shorter than that, 2 lines at most. So in the next video, we will see an improvement to this, and I'm going to hold off on testing this until the next video with my preferred format in the book. But the point is, this is what you want constructors for allocating memory dynamically, and then the destructors clean that up. And now when Bob, my application programmer, makes a contact info object, passes in a name and a phone number, all that stuff just happens automatically. And the fact that Bob is probably going to forget to call delete, it doesn't matter because he didn't need to. The object does it automatically. That's what you want. Okay, so we should practice making constructors and destructors. And my students and I would get together for this lab here, circles as a class, and there's a file circles.cpp, and we have to fill in code to implement this circles class, including a constructor that takes in the radius of the circle as an argument. And of course that makes sense because that's the fundamental thing you need to know about a circle. So when someone makes one of these circle objects, they can pass in a number that gets used as a radius to begin with. And that's probably what you want there. Of course, we'll test it, not the hardest lab in the world, but getting some more practice on constructors and destructors, because really every class is going to have those. And even if you don't write one, C++ makes constructors and destructors for you anyway. You actually can't avoid it. And every time you make an object, you call a constructor, and every time an object goes out of scope, the destructor gets called. That is happening automatically all the time, and that's super useful, super handy. So when we come back next time, we're going to be looking at some other options when you're making classes. Up until now, we've been making all of our member functions public so that the application programmers can access them. That's actually not the only option. You can absolutely make your member functions private. And we do that sometimes for functions that should only be called and should only be on the mind of the class programmer. So we'll see some examples of making functions private, which is a possibility, and also putting classes in arrays. I mean, you really don't just want one object. You're probably going to want 100 of them. So you can put objects in arrays, perfectly fine, just like with structs, frankly. You can get pointers to objects. You can dynamically allocate whole objects. So all those things are possibilities. You can probably fill in most of that yourself because they're very similar to what we've done with other types and structs in the past. But we should see those details next time, and I'll look forward to seeing you then for that.